Okay, this is the 44th question. 44, you know, this is the question. Right. This is the question. 44th one we haven't discussed in the classroom. Okay. Let's complete it now. Yeah. So there are 12 wires. Yeah. There are 12 wires. The sides of this cuboid are going to be 12 in number, right? Are actually 12 in number, right? Yeah. This is how the current flowing from the vertex point F is coming out. Right. So at first, in the first step, current travels through these three branches, right? AD, AD, AH, right? And it was clearly given each having equal resistance, each having equal resistance R. So each side has same resistance R. Right? So in the first step, obviously, the question is asking find the equivalent resistance between the diagonally opposite points A and F, as shown in the figure, right? Yeah. In the first step, the current flows through the branches AH, AD, AD, right? So let's mark them in the first step, right? As we know, AH, AB, and AD have same resistance, right? So the division is going to be same. The current division is going to be same. The I current is going to be I by 3, I by 3, I by 3. If I say the total current is I. Okay, so I by 3, I by 3, I by 3 means AB, AH, AD must be in parallel because all these three branches having same current, same draw, equally distributed. However, they are not at all. They are not at all series. Like can we? The current is getting divided there. When the current is getting divided and the drop is absolutely same, you know, and the current is divided between AB, AD, and AH in the first step, in the primary step, right? You can see they are going to be in parallel, and each branch having same resistors. So from A, I somehow can write like this. So we have hmm, so definitely A. నేనే ఆన్ చేసిన sorry guys. All these points are A. These are going to be, of course, HBD are also same. When you say HBD, all the three are going to be at some same potential. All the three same potential. Yeah. Okay. Um, in the first step, the resultant resistance is going to be R by 3, right? R, right? It's actually R by 3. And what happens in the next step is a bit complex to understand. So I just wanna jump onto the endpoint F from where the current comes out, right? So again, all the branches have same properties. Obviously, again, I have to consider CF, EF, GF. These things also should also, right, have the same resistance, even same, which is at the same point. C, E, C, with the same potential because the drop is absolutely same, no? Yeah. So where do I have to take? So let's take gain 3, and this is actually the, let's take these points C, the last step. These are the points of C, right? Just before the total current is out, E, right? So again, they are going to be R, R, right? So you should get R by 3. R by 3 is the last step. In the meanwhile, what are the branches you can see? You have DC, right? How many are there? Yeah. In the meanwhile, what we have? DC, next, BE, BC, BE, BC, BE, next. So I'm talking about, apart from these, C, G, E. Apart from these branches, what we are left with? We have AH, AB, AD, and CF, GF, EF, right? Apart from these branches, what are the leftover branches? DCBE in the second step, the exact DCBE, right? If you take A, AD is already done. So DG, DC, DG, DC. So take H, HG, HE, right? We covered all the branches. These are six. These are six. 6 plus 6, 12. Yeah. Again, these six branches are going to be in. branches in path. Okay. So in the first case, you got R by 3. This is how, the equivalent diagram. There will be 3 first. In the second step, there will be 6. 1, 2, 3, 4, 5, then 6. Now what are they? DE, DC, DG, DC, HG, HE. Okay. And then in the last step, we have another 3. What are these 3, right? So here it is A, this is A, this is A. So for this, it's gonna be R by 3. All the 3 are going to be in series. R by 3, R by 6, and again R by 3. This is the effective resistance. So R total is equals to R by 3 plus R by 6 plus, right? R by 3 plus R by 6 plus R by 3. So it's gonna be 2R by 3. So you can even write the branches here for that understanding. The branches in the first AH, AB, AD. AH, AB, and AD. And then the second step, what are the branches? The 6 branches, like here. These are the 6 branches. Okay, have been in parallel or in parallel. And the 3 branches again, in the last step, CF, GF, and EF. So here you got 2R by 3 plus R by 6. So you can write 4R by 6 plus R by 6. Bases are same. I mean, sorry, denominators are same. Numerators can be added up. So ultimately, the resultant resistance is 5R by 6. R total between A and F is equals to 5R by 6. Okay, this is the answer. Check answer the one. No? Question number 44, right? 5R by 6. You got correct one. I'm gonna share this map in the group. Make sure you copy this in the class. Cool. Right.